we will be starting out by looking at the difference quotient of a function at a point x equaling a. This is our topic for today. Generally speaking, for most students, this is the first interesting section that we have, so you should be paying attention. So, by the way, instead of writing difference quotient, can I write DQ? Is anybody going to think Dairy Queen if I write DQ?
Yeah.
Okay, good.
Yeah.
Someone's going to type Dairy Queen. I got to write the whole thing out. The difference quotient at the value x is defined as the limit as h goes to 0 of f of a plus h minus f of a divided by h. This is the formula for the difference quotient. You will need it on the test. It will not be given to you. You do need to take some time to memorize this formula right here. It's an advanced formula, but something that you definitely have to learn. The interesting thing about the difference quotient is that it is defined to always be an indeterminate form. It's a limit, correct? So I could always try direct substitution. And if I try direct substitution, i.e. everywhere I see h, I plug in 0, I will get f of a plus 0 minus f of a divided by 0. That's not a 0. And a plus 0 right here is simply a. And why do I keep writing the letter a too many times? And of course, this breaks down to 0 over 0. So the difference quotient, just by its definition, is designed to be an indeterminate form. Because of that, normally you can skip that first step of plugging the numbers in. But because of that, what we have to do is we have to simplify. And then try the direct substitution for h equaling 0 again. The problem is the simplification is not that straightforward. And so today we'll be learning that process of simplifying this entire expression. Questions? Comments? Queries? Concerns? All right, cool. We will do this through an example. So normally what you would see, something like this is how a question we worded on the test. It would say, find the Dairy Queen nearest to you and bring your professor some ice cream. Find the difference quotient of f of x is equals to 2x squared minus 3x plus 4 at x is equals to 3. That's what the question would look like. Are we all doing okay out there?
Yeah.
Yeah.
Yes.
Yes.
So you ever heard when your professor asks you to concentrate for a second or two? You ever had that happen to you before? You need to stop if you're on the phone, you need to stop it right now. If you're watching a little bit of YouTube, you need to stop all that right now. You need to focus for a few minutes. So based upon the equation right here, x right here in my example is equals to 3. And so what that means is that everywhere I see a in the formula, I am going to write the value 3. this is a difference quotient at x equals 3. So I'm using the difference quotient formula, and I'm plugging in 3 for a. All right, so far? Well, again, I know this is going to be an indeterminate form, and so I have to simplify this. To simplify this right here, I have to go through 4 steps before I can then plug in h equals 0. Step number 1 is I need to figure out what this is. Step number 1 is I got to figure out what this thing right here is. Step number 2, I got to then figure out what f of 3 is. Step number 3 is I have to then subtract the 2 answers that I just got from step 1 and step number 2. And then last but not least, step number 4 is I have to then divide the result by h. Now, these steps simplify as you go along. The first step is the hardest step, and each step is slightly easier than the step before. And so we will spend most of our time on step number 1, and then we will go from there. But any questions right here on how we're going to try on the concept of simplifying this expression?
No.
So, step number 1. I have to find f of 3 plus h. Well, this is f of x right here. F of 3 plus h means they want me to plug 3 plus h into this function. So if I look at the function carefully, I see the function starts out as 2x squared. And so therefore, this thing is going to be 2 times 3 plus h squared. The function then says minus 3x, so it's going to be minus 3 times 3 plus h, and then ends with plus 4, and that's going to be a plus 4 right here. Any questions on plugging in 3 plus h into the function? Okay, there's this lovely saying, it says, please excuse my dear Aunt Sally. She's in math class and she's going to be late because she enjoys doing it. Right. Well, then the parentheses kind of be simplified because they're terms. So the next thing I'm going to have to go to do is I'm going to have to do the exponents. And there's only one exponent right here. And so I got to simplify this thing right here. So I need a little bit of space to do this. So I'm going to do this on a new sheet of paper. I'll be right back. So I'm doing 3 plus h squared. That of course means 3 plus h times 3 plus h. Because 5 squared is 5 times 5. 10 squared is 10 times 10. And then from here, I have to FOIL this thing out. So starting the 3, I fire twice. 3 times 3 is 9. 3 times h is 3h. Then I go to the h and I fire twice. H times 3 is again 3h. And then h times h is h squared. The two middle terms are like terms, and so I can add them together. So that gives me 9 plus 6h plus h squared. Y'all remember how to do this from college algebra?
Yes.
Keep bringing that class up. It's like one of my favorite classes.
What happened with the 2?
Which two where? Which two where?
The 2 in front of the parentheses.
Oh, and we're going to put it, it's still there. We're going to go back and put it in.
Oh, all right.
Anybody else? So if somebody remember this for me, please. 9 plus 6h plus h squared. So back to where we were. So this is going to be 2 times 9 plus 6h plus h squared. Minus.
Don't you, well, are you supposed to do like the one with the exponent first and then with the variable and then the number? Does it matter at all?
It does not matter.
Okay.
But it's just easier to explain if I do them one at a time, you know.
Okay.
And then I have to distribute the 2. So So I fire 3 times. I got to distribute to the -3, so I fire twice. 2 times 9 is 18. 2 times 6 is 12h. 2 times h squared is 2h squared. -3 times 3 is -9. -3 times h is -3h plus 4. We're not done yet. I now group like terms together. I have a 2h, so that's 2h squared. Sorry, 2h squared. I have a 12h and I have a -3h. So those will combine to give me a positive 9h. And then I have an 18, a -9, and a -4. 18 minus 9 is 9. 9 plus 4 is 13. And that, my friends, is the end of step number 1. Questions there? Comments? Queries? Concerns? So that's step number 1 in the books right there. Step number 2 is to now find f of 3. And so that's simply going to be f of 3. That's going to be, again, I need the function. I have to plug in the 3 into the function up here. So that's going to be 2 times 3 squared minus 3 times 3 plus 4. And again, I got to follow PEMDAS. I got to square. So 3 squared is not 6. 3 squared is 9. I'm multiplying. 2 times 9 is 18. 3 times 3 is 9 plus 4. And then I can add these together. Wait a minute. Haven't I seen these 3 numbers somewhere before? 18, -9, and 4.
Was it in the previous equation? The one we just did?
18, -9, positive 4. I wonder why that happened. 18 minus 9 is 9. 9 plus 4 is 13. And that's the end of step number 2. Questions there?
Can we, can we just, for step number 2, can we just say that the last, so in the above equation, it was 2h squared plus 9h plus 13. Can we just say, okay, step 2 is 13? Is that always the case, or is it just a coincidence?
It actually will always be the case, but no, you cannot do that. You won't get credit. I give credit for each step, so you won't get credit. You have to actually do the step. You know, when you get fancy and you work in the real world, then you can take all the shortcuts you want. But for now, you actually got to work them out. So, with that in mind, step number 3 is to subtract the 2 answers. So, step number 3 says, start my step. Number 3 says, take the answer from the previous one, 2h squared plus 9h plus 13. And then from that, subtract the answer from the previous one, 13. Like I was just pointing out to you, or I was hoping to point out to you, these 2 numbers will always be, the last 2 numbers will always be the same. And so what happens for step 3? When I'm trying to simplify this right here, what happens? The 13s will?
Cancel out.
The 13s will say good night. And so that will leave me with 2h squared plus 9h. And that is the end of step number 3. See, like I tell you, every time you do a step, it gets shorter and simpler. And then the last step, step number 4, of our simplification process right here is to then divide by h. So you take the 2h squared plus 9h, you divide that by h. When you divide by h, what happens?
The H.
Cancels out the h's, other h's.
So this h, and this h all go away, and that leaves me with a 2h plus 9. So remember, this whole process was to simplify. It's a difference quotient, and so we're trying to simplify. So this huge, large expression after the end of step number 4 simplifies to limit as h goes to 0 of 2h plus 9. I do my direct substitution. That's going to be 2 times 0 plus 9 because h is going to 0. And that leaves me with the answer 9.